So now that we've covered the fundamentals of Solidity as a coding language, the fundamentals of working with an interactive development environment, as well as just fundamentals for coding, right? Just introductionary. I don't even know if I'm saying that word. That just the introduction of what these things are, from basic operators and working with basic algorithms. Now it's time to get deeper. Now it's time to build more interesting and exciting, fun smart contracts together. We're not going to stop at every little thing as much. I'm still going to do my best to emphasize how things work and to make sure that we're clear line for line. But we're going to dig a little bit deeper with Solidity in this section, okay? It's not going to be as crazy as our final application where things, just a heads up, they get pretty wild. But even in that section, we try to break everything down line by line. Then we go through it afterwards, and then we let it sit. We let you think about it. I constantly in this course do my best to stop. I don't just, when we code along, I'm not just coding for you. I'm stopping and I'm letting you think about it and trying things, and then giving you exercises as well sometimes so that you can practice these things for yourself, right? So that's a heads up on this section. Great work getting this far, and enough with the talking, right? Let's get back to the good stuff. Okay, so now you should be in remix.ethereum.org, and this is an IDE, and an IDE is basically an interactive development environment where we can actually write some code and then automatically compile that code and see it in action. We can bring in plugins. We can do compiling, and this is one specifically derived for Solidity. So we can actually write up smart contracts in our IDE and test them. We can test basic migrations, and we can test out different tokenomics. So when you go to remix.ethereum.org, you're basically going to see a dashboard where we have, like we'd have in a text editor, we see our files and our folders. So this is our directories in our workspace. And if we click through on our side tab, we see that we can go to different options. We have a Solidity compiler, which is going to let us to compile our contracts down. As easy as that. We just compile when we're done writing. We have a deploy and run transactions, so we can actually deploy our contracts up to the blockchain, deploy our contracts up to the Ethereum blockchain in different networks, and then actually run transactions and see how that goes. We have unit testing, so we can run tests. And then we could add different plugins. And we can see already the plugins which are available. So we have the Solidity compiler, which we're going to use, the logic for the compiler, which we're going to use, and unit testing is active right now. And then we see there are all these plugins that we could actually activate. And we can actually search through to find other plugins as well. Okay, awesome. So what we're going to essentially do is we're going to go here in this main page, we're going to create a new file. So what we're going to do here is we're going to create a new file. So we're going to click on new file over here in our main page, and we're going to call it will.sol. And the sol stands for Solidity. That's how our IDE knows that we're going to be coding in Solidity. Okay, so what we're going to do is create a new file, and we're going to call this file will.sol. And the sol is for Solidity. So this allows our IDE to actually detect Solidity, but we still have to bring Solidity into the file, right? We have to actually express explicitly that we're using Solidity. And how do we do that? Well, we type in pragma. Oops, if I can spell pragma. And here, let's try to make that a little bit larger so you can see it better. Okay, so pragma and then Solidity. We're going to use any version that's above 0.5.7. And then we add a semicolon. Remember, it's important to add our semicolons in Solidity. It's very sensitive. Okay, excellent. So now we've effectively set up our Solidity. We can actually start coding some smart contract data. And we do that by actually instantiating the contract. And Solidity registers the contract by bringing in contract like that, and then titling the contract. So our contract's going to be called will, and then like JavaScript, we create will into an object. And so what are we talking about here? So let's just remember what we're doing. So basically, we want to create a smart contract that when when our great grandfather passes away, or our great great grandfather or grandfather or whatever, whenever they pass away, they have everything predefined. So we create this will so that whenever our friend's great grandfather passes away, he stated to us, he says, I really love my great grandson more than my great granddaughter for some weird reason. I want to give my great grandson 20 ether, and my great granddaughter, she's going to get my collection of ties and only get, half an ether. All right, so we got to have all these terms and conditions. We got to have all this kind of set up, as we said in the beginning. We got to know where we stand. So how do we translate that into Solidity language? Well, what we want to do is actually look at the most important things that our smart contract can analyze. And what I can think of here is there's going to be an address, right? So we're going to want the grandfather's address, okay? We're going to want an integer. We're going to want the amount, right? Like how much. We're going to want to be working with a variable that's going to represent the amount, right? And then we're going to want to have a mechanism to check whether or not the grandfather is deceased, right? That we're not actually going to focus on hooking up to any obituary oracles or anything like that. The point isn't that. The point is that the three things that we need is to be able to check when our friend's grandfather is, has passed away, has passed on, the amount of his fortune, of how much, inheritance, and then we want his address. So the owner's address, which would be our friend's grandfather's address of his wallet where his account is stored. So how do we set this up in Solidity is a static language. So you actually have to declare your variables. And what do I mean by that? Well, when we want to set up an address for the owner, we actually have to type in address and owner. And address is a special type that goes with the variable. So whenever we declare a variable, we have to declare the types, and that is how Solidity works. So for the owner, we know that we want to associate our variable owner with address. That's why we put address next to owner. Okay. Now we also want to have the fortune, right? So we're going to write out fortune. And what is fortune going to be? Well, fortune is going to be an integer, and we actually declare an integer in Solidity by typing in uint. Okay, and you're going to see, actually, I don't know if you noticed that, but when I typed in uint, you see that we have all these different options for uints, and these options actually can help specify the type of integer we want in terms of bytes. But for this fortune, we don't have to worry about it, so we're just going to keep it a general integer. Later on in the course, we're going to get more into the specific types of integers and when they become useful. But for now, we're just going to declare a fortune to be an integer, an owner to be an address, and what's the third thing, if you remember? Well, we're going to check to see whether or not our friend's grandfather is deceased. And we do that by actually typing in, by declaring a variable deceased. And we set this to a Boolean. And we do that just by typing in bool. And now a Boolean in coding language is something that either returns true or false. Okay, it's checking the validity of something. So when we set our deceased as a Boolean, it is set up as a Boolean that's either true or false. Okay, and those are our three variables which we're going to be defining in this contract and using. Okay, so now that we've created our variables in our contract, the next thing that we want to create together is a constructor function. So what is a constructor? Well, a constructor is a special type of function that's going to execute when we deploy our Solidity smart contract. So we make a constructor just by writing in constructor, okay? And then it's a function. We bring in our argument brackets. And then what we're going to do is have our curly brackets to put the object information in the function, just like with JavaScript. This is very similar to JavaScript. And we're actually going to make this constructor public. And the public keyword in Solidity is another very important keyword. So public, what it does is that it grants visibility. You're enabling this function to be called within this contract, but also outside of this contract too. So Now we're going to add another special keyword to our constructor as well, and that's going to be payable. And payable is also another very important and special keyword in Solidity. Okay, so we are allowing this function to send and receive Ether, and that's what makes it very special. Once we deploy this contract with payable, we're going to be able to initialize our fortune with an Ether balance. So we're going to give this Ether balance to the constructor now, and we're going to give it a Ether balance of 50. And we're just going to do this just to demonstrate how everything's going to work. Let's set our variables here in our constructor and initialize them to something. So what should we set them to? Well, the owner, we're going to set it equal. So we're going to write owner equals msg.sender. All right. And I'm going to explain this in a second. So, all right. So what is msg.sender? Well, msg stands for message. And what this really means is that the owner is going to be representation of who is calling this address. So whoever is calling this address, it's a representation of the address that is calling the function. It's okay if that doesn't make any sense yet, but essentially what this means is that we're going to set the message sender to the owner. And in this case, the owner is going to be our friend's great-grandfather or our friend's grandfather or whatever. So what we are effectively doing is we are setting up an address, and it's called owner, and then we are setting up this address to be the person who is actually calling the contract, the person who's executing the contract, which is going to be us. And again, if that doesn't make sense yet, don't worry. It's going to make a lot more sense when we actually execute this contract and we go through how everything works. So for now, don't worry, and we're going to keep going through it together. So we add a semicolon, The next thing we want to look at is fortune. So what is the fortune going to equal? Well, just like how the owner equals message.sender, the fortune is going to actually be message.value. And message.value, essentially, it's another built-in global method, or another built-in method in message, value, and sender that's built in. And what value does effectively is just show us how much Ether is being sent. Okay, so message sender calls represents address that is being called, whereas message value tells us how much Ether is being sent. Okay. And finally, we can't forget deceased, right? So deceased. And we're actually going to set up deceased to false. And we're going to do this because logically speaking, we're going to assume that from how our contract is initially executed, how our contract is initially being set up, our friend's grandfather is still not deceased. So we're just going to start it that way and say this is false for now, and then we're going to switch it to true and then see if our smart contract works together. So this is actually, believe it or not, a big chunk of what Solidity is, of what you need to know in Solidity to build. And it's really not that bad, right? I mean, we set variables. We have to actually statically say what they are, and that's how we do that. And then we write this constructor to deploy our contract. And so moving forward, the next thing that we can take a look at are modifiers. And what are modifiers in Solidity? Well, modifiers are add-ons for our functions that can create additional logic for them. And a very common use case for this, of course, would be conditional statements. So modifiers could be useful here for two reasons. We're going to do it for two things. The first thing is for the address. We can create a modifier. So create modifier. So the only person who can call this contract, is the owner. Okay. And we can also create a modifier so that we only allocate funds if friend's gramps deceased. Okay. So these are the two cases where we would do this. All right. So the only person who can call the contract is the owner, and one to allocate funds. All right. So how do we do this? Well, we actually create modifier functions. It's very static. We just type in modifier. And then we set the name, just like a variable. So let's say we do one called only owner. And let me just zoom in here. Only owner. And here we're going to require, and what do we want to require? Well, we want to require that the message sender has to equal the owner. So require is a conditional statement that we can bring in, such as an if conditional. And we can say require, just like in a conditional statement, we can say msg.sender has to equal the owner. And just like in JavaScript, we use two equals to say that these two things need to be equivalent to each other. There's a difference between 1, 2, and 3, right? 3 is unconditionally they have to be equal to each other. 2 is they have to be equal to each other. And 1 is essentially that, and 1 means that this equals this, and that's not true. Here we just want them to be equal to each other. And if that's a little bit confusing and you're new to JavaScript and programming, don't worry, just keep going and it'll make sense as we continue on. We're going to use this operator a lot in this course and it'll make sense the more we use it. Okay, so we add a semicolon and now we're going to just add a underscore and another semicolon. Now what does this underscore do? Well, the underscore just tells the function to continue. So essentially it just means to shift to the actual function after we've run this modifier. So we're saying that if with this modifier, whatever we want to do can only happen if the message sender does equal the owner, is equal to the owner. So the person who's calling the contract has to be the owner. All right. And then after that's done, shift back to the function, get back to work. If not, then it's not going to continue the function, and that's how we're going to prevent this. I mean, that's how we're going to prevent other people who aren't the owner from accessing this. So hopefully that's making a little bit of sense. Again, once we see it in action, it will make more sense. Okay, so let's make another modifier. So I'm going to copy this one, and I'm just going to paste it underneath here. And this one is going to be another condition. We're going to say, essentially, it's a modifier that's going to check to see that our friend's grandfather must be deceased. And here we just have to require what exactly? Well, it's a Boolean, right? So if you remember in our construction payable, when we initialize our deceased, we set it to false because it's a Boolean. We create a deceased, it could be true or false. So we set it to false because we're saying, well, we don't know because right now he's alive, our friend's great-grandfather. But when this happens, then we're going to switch it to true. But when we switch it to true, then the smart contract is going to allocate funds. But here, what we're doing is we're requiring that he must be deceased. So what should we write in our requirement here? So go ahead and pause the video and see if you can figure that out on your own. Okay, so hopefully you had some success with that. In any case, let's do it together. So what you should write, so the argument here should be very simple, right? Essentially, we should say, well, deceased is going to equal true, right? Well, almost. It's not going to equal true, but it must be equal to true, just like with the message sender. Okay, so if you did that, that's awesome. That essentially is going to be our modifier saying that there's a requirement that the gramps must be deceased, and it's going to come in much handy, and it's going to come in pretty handy in just a moment. So both of these modifiers, if they're not making sense yet, that's fine because they're not doing anything just yet. But when we put them into action, they're going to make much more sense. Okay, so now that we have our constructor, we have our we have our global variable set up and some modifiers, let's create a list to store the wallet addresses of those who will be inheriting the Ethereum or the loot from our friend's grandfather. So our friend and let's say his sister Lisa, and his sister Susie, and our friend John. Okay, so we want to have a list where we have access to those addresses. So how do we do that in Solidity? How do we create something that can store a list? Well, we're going to just create an array. We do that by making these square brackets. Oops, I don't know if you can smooth that. See, so we create square brackets over here, and that is an array. And then we can actually call this array family wallets, right? So this array is going to store all of the addresses. And what's an array? Well, essentially an array is a list of items. So inside of an array, you can put things inside of an array. So inside of an array, you can have numbers, for example. So you can say 1, 2, 3, 4. You can have larger numbers, right? And so this would be like addresses, right? You can also have colors. You can have red and green and blue. And you see how they're separated by a comma? So this is essentially what an array is. And so it makes sense that if we're creating a list, we want to store that list inside of this, an array. So when we do this, so when we put an empty array, we initialize the array as empty, and we're calling it family wallets. Now we also want it to be addresses, so we write in address like this. And finally, we want this array to be payable as well, right? Just like we made our constructor payable and we initiated so that we can bring Ether into that, we want to also be able to send and receive Ether into the family wallets over here, because we want to send Ether over into these wallets. So we're going to make this payable as well. So and that's it. That's all it takes to create an address for family wallets. It's just 3 words and a square. And or a rectangle. Sorry, it's just a square. It's a rectangle. Now, next up, we're going to do something that's a little bit more tricky, but it's really not that bad. We have this list, right? But then we're going to need to actually keep track of which address is what, and who gets what and how much. And how are we going to do that? Well, we do that by actually creating a key store value in Solidity. And how do we create a key store value? Well, we do this with a method called mapping. Just like we would do in JavaScript with map, we can use something called mapping. And if you're new to looping and you're new to key store values and that, then it can be quite confusing at first, but don't worry about it. Just roll with it and practice it and learn about it, and it's going to become something that makes a lot of sense because it's super useful. We use it a lot. You use it a lot in coding. You're constantly iterating through things. What is iterating? Iteration? Iterating just means looping through. And when we map through something, we iterate through store value of keys, right? Store value, key store value, okay? Anyway, let me get rid of that. So how do we bring in this mapping? Well, it's just like anything else. We type in mapping for real. So we go mapping, okay? And then now mapping, we set up our argument, and inside our argument, we put in what we want to be mapping, essentially. And what we want to map are the addresses. So we're going to say address, and then we have an arrow function here, so that each address is going to have its own uint, its own integer, okay? And we map through that, and now we can actually name this mapping. And what do you think this should actually be called? Well, what are we mapping through, essentially? Essentially, we're mapping through the inheritance. So let's just call it inheritance, okay? Trying to just get the size so you can read everything nice and clearly. Okay, so now we have our mapping set up. So now that we have our list for the wallets and we have a mapping for our inheritance, we need to create a function that actually sets the inheritance for each address. So set inheritance for each address, okay? And this we can say is list of family wallets. And this is to map through inheritance. Okay. Okay, and make sure that you're still coding in the contract, right? It's very important to be careful of the scope. And what do I mean by scope? Well, scope is where you set your variables and your functions is important to the scope that is defined as the boundary of what it should understand and what it shouldn't understand. Basically, the zone or the world of information that you create. So right now, we want to be in our contract still. Okay, so let's create this function. Okay, let me zoom in. So we're going to say function set inheritance, and it's going to take 2 arguments. It's going to take the wallet and inherit wallet and amount, right? And remember we have to define these statically. What are the types? So what's amount going to be? Go ahead and put in the amount of what you think it should be to declare it. How you think we should declare amount. Okay, so hopefully you wrote uint, and now try for the wallet. See if you can figure out the wallet. Well, the wallet should be address, right? So if you put address, that's awesome. You are getting this. If not, don't worry, we're going to go through this so much. But it's not just going to be address. We also want this to be payable because we're going to be sending Ethereum and receiving Ethereum. So address, payable, wallet. Okay, so these are the arguments. And then now we can actually go ahead and write out the logic in our function. Oh, and also I want to make this function visible as well. So we're going to make it public. All right. So what do we want to do in this function? Well, we want to map through our wallets, of our family wallets, and then add the actual wallets that should be there, right? And that's the payable wallet. So how do we do that? Well, go ahead and pause the video and see if you can actually do that. So I'm going to write the comment of what you need to do. So your exercise here is to figure out the logic to write to add wallets to the family wallets. And I'm going to give you a hint. You should use the JavaScript method push. So if you don't know what push is, you should Google and look up push because we can use this in Solidity as well. So go ahead, pause the video, give it your best shot, and again, if you're totally new, you don't have to try this. We're going to do this together in a second. Okay, so hopefully you had some success. Let's give it a go together. So to write this functionality, all we really have to do is say family wallets dot push, and what do we want to push? And what do we want to push? Well, we want to push in our argument of wallet, right? Because we're going to bring in a wallet and we're going to bring in an amount. So we're going to say push the wallet. Okay, and that's how we're going to get the wallet. Now, what about the amount? How do we do that? Wow, how do we set up the amount? Well, we can do that with our inheritance, right? So each inheritance is going to have a key store value. So what we can do is we can say inheritance of what? Inheritance of each wallet. What do we want to make the wallet? Well, to our second argument, right? It should be to the amount. Essentially, what did we do here? We created a list of family wallets, right, with an empty array, and we made it payable so it can receive Ether. We set it up as addresses, and we call it, we instantiate it as family wallets. Then we have a key store value, a mapping that we set up. It's sort of like a dictionary that you can create. And what we're doing is we're setting each address as an integer for our inheritance, right? That's going to be the inheritance to map through our inheritance. Then finally, we set inheritance for each address. And that's a function to do that. So we create a function called setInheritance. It takes 2 arguments, which is the wallet and the amount. And what we run inside this function is we bring in the list, okay, our family wallets, and then we push through the list, and then we add to the list the wallet that's going into the function, all right? So that's our first argument, okay, and that's going to be an address as well. After we do that, our inheritance, so we do a mapping for that wallet, and that is going to be what? To keep track, and that's how we keep track of it. And that's going to be what? Well, that's going to be the amount. So with this function, we're able to actually set up all of our inheritances, set up the inheritance for our grandfather's friend or great-grandfather's friend, right? We're going to be able to say, hey, this is the wallet address of our friend, John, and John gets X amount. And this is the wallet address of Susie, his sister. Susie gets only this amount. Okay. Once we see this executed, it's going to be much more clear. We're going to actually see us put in the information and see the wallets get distributed. Okay, so we are almost actually done with writing out all the code for our smart contract. Really not that bad to create something that can provide a lot of value with some basic fundamental coding, right? So let's just create one more let's just create one more addition to this contract so that we can make our lives easier and make sure that everyone gets paid. And what would be a great thing to add to this contract would actually be a way for us to automate the payments. So we can actually pay each family member based on wallet, based on their wallet address. Okay, so this is going to be a function essentially that's going to check through each wallet that's added, each wallet, and then send money based on each wallet. Okay, so how do we do that? So we're going to create another function. All right, and let's call it function payout. And we're going to add actually our modifier here. We're going to say that in order for the payout to even happen, what should happen? Well, we don't want to pay anyone out before our friend's grandfather is deceased, so we can actually bring in our modifier, must be deceased. So we can copy this and paste it just like that. So this function will only run this modifier, so the deceased has to be true. And that makes sense, right? And that modifier should make sense, right? We don't want to pay people out before that. So this is a condition. So hopefully now this modifier makes a lot more sense why we devised it. And the other thing is we don't want other people to be able to access this function. We want to be the only ones to access it. So we're actually going to make it private. This is not going to be public, okay? So we're going to set it to private. And now we have our function payout. And inside of here, what we're going to do is we're going to create a for loop. Now, what is a for loop? So a for loop in JavaScript, a for loop in Solidity, essentially, it's a way to iterate, to loop through something from start to finish where you set the parameters and conditions. So you can, a for loop, so with a for loop, you can loop through things and set conditions, okay? And there's a syntax that you get pretty used to with for loops in JavaScript, and they make use of this in Solidity as well. So what you want to do to bring in a for loop is you type in for, okay, and then like an if condition, you bring in parentheses. Let me try to zoom in. I'm having some trouble. All right, I was having a little trouble zooming in. Okay, for. Okay, and then what you want to do is we're going to work with an index, and we're going to call this index I, and the index is what keeps track of each iteration. So first we initialize where our index should start, and that should be 0. Oops, 0. So we say I equals 0. The second part of our for loop is always going to be how long is I going to run until? And we're going to run, and how long do we want to run it for? Well, we want to run it for the amount of family wallets in this list, right? So we're going to say I should be less than family wallets dot length, right? Right? Because that way it's only going to run up until the point that the length is completed. So if we have 3 addresses, we don't know how many addresses are going to be in the family. Right now we think it's 2. Maybe there'll be another person added in the family, that like the dog or something. So we're just going to run it for the total length of the family wallets, because anyway, that is our list. That's what we have in our list, and we don't know how long that list is going to really be necessarily. So we do family wallets.length, and then finally we do I++. And I++, the plus essentially is a way of saying +1. It's a way of saying add 1 afterwards to the index. So I starts at 0. We go through the first address, then we add 1 to I. So then I becomes 1. We go through the second address, and then we give that index 1. We go through the third address, we go ++, I equals 2, and so on and so forth. And we keep adding that way. And that's how we keep track as we're iterating. And now, if this whole syntax, it looks really confusing, and it's hard to follow what I'm saying right now because you've never actually coded a for loop before. That's totally normal. It's generally very confusing for people the first time they look at a for loop. It's really something that you just get used to because you write these loops a lot. Generally, you want to iterate over things, and when you do that, these for loops come in super handy. Okay, and so this is essentially just the parameters. That's all we did. We just set up the parameters of the loop. Now we need to tell the loop what to do as it is iterating. So we're going to open up 2 more curly brackets like that. Okay, and this code is a little bit tricky. So what I'm going to do is I'm going to write the code out first, And then we're going to go through it all step by step, because this is essentially the logic in here is what we want to do. And logic in here is what we've been talking about this whole time and talking about doing this whole time. And what is that exactly? That is actually to go through each address and then transfer, based on the index, the amount to each wallet, right? So we want to transfer the amount to each wallet with this payout. And we do that with the index as we are iterating through. So my first question to you then, which list are we iterating through? Well, it's the family wallets, right? So what we do is we can say family wallets of I. So we bring in the array of where we are in the iteration. So family wallets of I, when we are iterating through, and then through each iteration, we can do something. And what do we want to do? Well, we want to transfer money, right? We want to transfer the Ethereum to these wallets. And we can actually leverage another really important from Solidity, and that's transfer. And so .transfer is really powerful for transferring, of course. And the transfer takes an argument, and that argument is going to be the amount. All right, it always takes that argument. Transfer always takes this argument of the amount. Okay, and I'm just trying to fix the zooming a bit. Okay, and so what is the amount? Well, the amount that we want is going to be from the inheritance, right? And it's going to be specifically the inheritance of what? Well, of our iteration of the family of wallets. So we want to transfer to our family wallets the inheritance of the family wallets of each index. So this line of code right here, what it's doing essentially is that it's transferring the funds from contract address to receiver address. And it does it pulling through the family wallets list. And okay, if this line is really confusing, that's normal. Let's go through this function one more time so we can really try to make sense of it. So essentially what we're saying is that we're making a payout function where we can pay out the inheritance to each wallet address. Okay? And then we say that it must be deceased, so our great-grandfather must be deceased. That's our modifier. And we create a loop. And our loop is just iterating. It starts at 0, and it goes through each wallet that's going to be inside here, okay? Now, in our set inheritance, remember, this is where we're keeping track of the amount of each wallet, right? We set our inheritance here, and we have it to the wallet, and we set it to the amount on our second argument. And this is going to make a lot more sense once we actually deploy it. But just try to visualize this if you can, okay? So what do we do when we're iterating? Well, what we say is that we transfer funds. So we're going to be looking at each family wallet, okay, at each index in our iteration of the family wallet, and then we're going to transfer an amount. And what amount are we going to be transferring? How do we find that amount? And our transfer is going to be the inheritance, right, what we're mapping through, so what our key store value is, so our address per thing, and we're setting the inheritance to each family wallet at the index where it is, okay? So that's the amount. That's how we're going to find the amount, if you remember from the mapping. And then we get the family wallet here from our list. And then we actually use this function, the set inheritance, to add the addresses and add the amounts, okay? So hopefully that makes sense, right? So this function is going to set the addresses. This function is going to set the amounts of the inheritance for each address. And then this function is going to pay out based on this. And it does it by transferring with each and it does this by transferring the amounts of the inheritance, at where we are in each index in the family wallet iteration. So we're going to pay each family wallet, and then when it's done, when we've done it all, we're not paying anybody else. It's over. The loop ends. All right, that's a bit of a mouthful. Hopefully that makes more sense. If not, it's okay. It's all right. Have a glass of water. But we're not done yet. We're going to actually see this puppy in action. So we're going to set this smart contract, this theoretical smart contract, and actually deploy it, and run some transactions on it. And when we do that, we're going to recap. So take a break. You deserve it. Let's deploy this puppy out. Okay, I'll see you there. Bye. Okay, so let's just review what we wrote for the smart contract and what we did to create a will as a smart contract, to turn this will into a application. So what we did effectively is we bring in Solidity. We said that we want any version higher than 0.57. Then we create a contract. We call it will. By creating a contract, we get access to all sorts of variables and methods and functions that we can call that come with our contract. So after that, we thought to ourselves, well, you know what are the important things we need to bring in order to make this contract work? And it's that we need the owner, because this is going to be the will of a friend's great-grandfather. So there needs to be an address where all the loot is stored, right? So that's that address. And then when we set the owner as an address, we create an integer, which is the amount. That's the fortune, and we publicly declare it by typing uint. And then we create a switch. And it's like an on and off switch to see whether or not our friend's Gramps is deceased, right? And we do that with a bool. So just like that, we set up our global variables of what we want to use here. After that, we create a constructor. And the constructor is a special function which then allows us to actually get access, to our owner, our fortune and deceased when we're deploying our contract. And we go into much deeper details into constructors with JavaScript when we're working with React later on in the course. But for now, we can keep it at that. We can leave it at that. We create this constructor. We make it public, meaning that it becomes visible, so we can use it outside of the smart contract. And it's payable as well, meaning that we can actually initialize it with some ether, because we want to send some ether into it, because nobody's going to be sending us any ether anyway, because we need to have some kind of payment. We need to have some ether in it, right, to do it. We actually initialize our global variables. So we set our owner to the message sender. Message is another global variable from Solidity, which gets access to sender. And what that means is the owner is going to be the sender that represents the address that is being called. Okay, so we set it to that owner, which is going to be effectively us, right? Then we have the fortune, and the fortune is going to be the message value, which is going to just tell us how much ether is being sent. And then we set the deceased to false. So we're setting up our contract and we're saying, well, so far, no, this hasn't happened yet. But when it does happen, that's when we execute this contract. After that, we created these modifiers. We said, well, we're going to create extensions to our functions. So we said, well, we're going to do two. We're going to have an only owner. So this makes sure that only the owner can access that. And then the other one is that it must be deceased. So this function is must be deceased, and that must equal true as well. And remember, these are modifiers, so we can add these now to our functions, which we do down here, as you see, function payout. When we make our payout function, we say we can only run this if deceased equals true, otherwise you're not allowed to run this. And actually, I just realized something else. The set inheritance, only the owner should be able to do that, and we forgot to add that. So I'm just going to say only owner. I'm going to copy only owner here and add it after public. It's okay if you didn't do that before, or if you even skip it, but just out of principle, so you understand what's going on, hopefully that makes sense. The only person who should be able to set the inheritance is going to be the grandfather, right? He's the one who's writing the will. He's the one who should be setting the inheritance. Nobody else should be allowed to do it. So only the owner can run that. That's how we do that with the modifier. And those are our modifiers. And then finally, we need to create a list where we can store the family wallets of the inheritance, right? Of the inheritors, those who will be inheriting. So we need those addresses. We create a list, and then we also need to be able to map through that. And so each address will get a special store value that we can keep track of. And why are these things important? Well, these are important because when we set our inheritance, now with our list, we can have a special function where we can push addresses and amounts to add to our list and keep track of the amounts per each wallet that we're adding to. finally, we create a for loop, which will essentially be our payout function. And this payout is going to effectively run through all of the wallets that are in our list and then pay each person their amount until the list is complete. And we do that with this .transfer, which is super powerful in smart contracts and Solidity. And we use it, and you use it in pretty much all ERC20, and you use it in all ERC20 tokens. As we're going to see when we build our own, actual smart contracts, not on the IDE but on our development server, and we build our own tokens together. All right, that's it for a recap of what we did. In the next video, let's go ahead and actually deploy it for real this time. Okay, great work going through that again. Hopefully that all helped to put everything together. Let's take it a step even further in the next video. Before we deploy this out, I realized one thing. We forgot to add a final function here. And does that mean there's something wrong with the code? No, all the code is fine. It's great. But what we forgot to add is a deceased trigger. So essentially, we're saying right now in our code that, yeah, our friend's grandfather is not deceased. So we're setting it to false, right? We're saying, nope, not deceased. And then we're actually creating this requirement that deceased must be true. So we can't actually run our payout unless the deceased changes to true, right? And right now it's false, so we're never going to be able to run it. So let's create that deceased trigger. That's sad. It's going to be a sad day when that happens. Now, if this was a real world smart contract, we would connect this to an oracle, and the oracle essentially would trigger the deceased. We'd create functionality to say, which will send us the information to say, yes, he's deceased, obituary confirms blah, blah, blah. Then automatically we trigger the button. All right, so what do we do to write this out? Well, what we want to do is create another function. And we're going to call this function deceased. Very sad, I know. It's a very sad function. And we're going to make this function public so we have access to it. And we're going to say that only the owner can actually trigger this function. In this case, only the owner is us, right? Or those who are going to be in charge of the inheritance wallet. So whoever has that inheritance wallet, I guess the lawyers or the bank, those lawyers or whatever, they're going to have access to this deceased button that they can then trigger. Okay, and so now we're going to set deceased to true because this is going to essentially trigger and change the morbidity status. I guess I'm going to call it the morbidity status of our friend's great grandfather. So we're going to say is deceased. We're going to set it to true. Okay, and this is not equal to true. This is actually setting is deceased to true. So we're switching the Boolean over from false, right, where we initially have it in our constructor as false, and now when we run our isDeceased function, we're switching it to true. Okay, so we're going to add a semicolon, and we're going to add one final. One final line of logic. And can you guess what that final line is going to be? Well, the final line is actually going to be the payout, right? We want to actually call the payout because we're never actually calling this function payout, which iterates through and distributes the wallet addresses that we set in the inheritance. So in order to do that, we're going to say payout. We're going to call this function within this function and then just put our semicolon. Hopefully that makes sense. It should basically just follow a logical pattern here that we're seeing. So we've got our payout function. Our payout function is going to be iterating all the information from our inheritance and transferring the funds over, okay, from the family wallet to the family wallets. And then our deceased function essentially is a switch that says, all right, this information has happened. Something has changed in the real world. This is the oracle switch in a sense. I can even say, listen, oracle simulated switch, okay, or oracle switch simulation, okay, and then this will change the status to true. That okay, unfortunately, this person is now deceased. The information has come that he's passed on, and now we can actually execute the payout function. So we call the payout function. Okay, so that's the final piece of the puzzle right here. I know we already went through everything, and maybe you were excited to deploy, but now I promise in the next video it actually is for real this time. Time to deploy this contract and see it in action. So go ahead, take a break, have another coffee sip or whatever you need to do, and I'll see you in the next video. All right. So now comes the good part. It's time to deploy this contract. Now, when we deploy the contract, it's very possible that we're going to run into errors, right? You know, I'm not perfect. I don't know if you're perfect. Most people generally aren't. And a huge part, I would say I'd say a very big essential part of coding is that you just spend a lot of your time looking through for errors, fixing bugs, debugging. So debugging is a very important skill to work on. So let's go ahead and hit deploy. Hopefully there's not going to be too many issues. So to deploy, the first thing we're going to do is compile the contract. So we want to switch our tab over here to the Solidity compiler and click on compile. Now it's going to run a compilation and compile down our Solidity contract. And if there's errors, it's going to debug them. It's going to let us know where our errors are so we can debug. So we see where I'm actually having an error right now on line 31. And we can actually read the error down here, and it says will.sol 31.5 parse error. So expected a semicolon but got mapping. So what does that mean? Well, like I mentioned, we need to be putting our semicolons in, and I forgot to put it over inheritance here. So I'm going to add a semicolon, and now I'm going to save. And actually, not only do I need a semicolon over on inheritance, but I noticed I didn't put it on family wallets. And that's probably why it says mapping, because it was expecting a semicolon before mapping. So I'm going to save again. Parse error, expected a semicolon. So I made another semicolon error. Let's see, zoom out. All right, so after our loop, I should put a semicolon as well. Save that. Okay, now I'm getting this declaration error. It says identifier already declared, function deceased, public only owner, undeclared identifier. Wow. Okay. So it's just kind of repeating itself. So I see there's a couple of places where it's highlighting for us to check. The first error that I see here is actually, let me just zoom it in a little bit. So the first error actually is this for loop over here. So if this was just JavaScript, there would be no error. This would be fine syntax. What we have here is actually the standard for I for a for loop. So you set up your I, as I said, then we are iterating, then I++. But because this isn't JavaScript, we never actually define what I is in Solidity here. Because remember, in Solidity, we need to declare what I is. In JavaScript, JavaScript would know automatically that I is an integer because we're setting it to 0. So it's going to declare automatically I as an integer. But in Solidity, we have to actually declare it. So I'm going to add a uint and save. All right, that took care of that. And finally, we see that this identifier deceased has already been declared. So let me see if I already declared this. Oh, and so I can't actually call this function deceased because our variable here in our contract is already being used as deceased over here. So I'm going to change the name of our function. Let me zoom in. I'm going to change the name of our function deceased to has deceased, and it's going to be a trigger like that, and we're going to save. Oh, and I see that is deceased is undeclared. So is deceased is actually supposed to be, and maybe you spotted this, it's just supposed to be deceased. So we're going to change is deceased to deceased in our has deceased function. Hopefully that's not too confusing. Let me just run through that. Save. Okay, so I just saved and we see that there's no more errors, which is good. But just to clarify the whole deceased thing, we created a Boolean called deceased, and that's our switch to check whether or not our friend's grandfather is deceased or not, right? Then we set it to false, and we called it deceased. Then I made a function called deceased, but I couldn't do that. That was an error because we already had this variable deceased. So I had to change it to has deceased because this function, essentially, we trigger it after the person has passed away, so we call it has deceased. Now, the other mistake in here was that I switched the Boolean deceased to true, but I called it is deceased by mistake, when in fact it should just be deceased because deceased is false, and what we want to do is switch it to true. So hopefully that makes sense. If that doesn't make sense, go through this again slowly because this is switching from true to false, and it's just a question of following the variable layout and the global scope versus the local scope. And if you're having trouble with that as a beginner, that's totally fine. So you just need to take the time to go through it. So now that we've fixed up all the errors, I'm going to click compile, and we can check the compilation details if we want. You can see bytecodes, and we're not going to go into all the compilation details here because we look at it much more in depth when we're checking out, when we spit out JSON versions of our codes and we look at our APIs and our addresses. It's okay if you don't know what any of that means. We're going to discover all that together later on when we get deeper into this course. Okay, so now that we have successfully compiled down our contract, we should see no error messages popping up in our console. So this console down here essentially allows us to do debugging. So we can take a look. We can actually change the length. If you put your mouse over an area, you can lift it by clicking and dragging, and then you can actually see what's going on. So we've done a compile now without any bugs. We cleaned up our errors, and now it's time to actually deploy our smart contract onto the blockchain. So in order to do that, we're going to now switch tabs from Solidity Compiler, which is the third one. We know we're on this tab because there's a check mark, to the next tab, which is deploy. Now the deploy and run transaction over here is where we can actually deploy the contract and actually run these functions. So this function set inheritance, this function has deceased, is going to become available for us to actually enact upon. Okay. And we're going to see how in a second, because our deployer essentially is a GUI which is going to allow us to essentially trigger these functions. So at the top we see environment, JavaScript VM Berlin, that's a virtual machine. We can switch to London, Berlin. We have these options, injected Web3. We're going to stay with JavaScript VM in order to do this. We're going to use injected Web3 and learn more about Web3 later on in the course. But for now, we're going to keep this at JavaScript VM. Now, when we click on account, we're going to notice that we have 10 accounts, each allocated 100 Ether. So we are given actually these 10 accounts for free, and all this Ether is given to us for free. Now, don't get too excited. It's not real Ether. This is test accounts on test Ether because we are running on a test network on the blockchain. So we are running on the Ethereum blockchain, but we are essentially running on a test network, not the main network. Now, underneath account, we're going to see gas limit. The gas limit is essentially the fees that we're going to be paying. Now, what do I mean by fees? Well, gas fees, right? Every time you do a transaction on the blockchain, there is a protocol so that it takes a certain gas fee to complete the transaction. Ethereum during its bull run of 2021 in the first quarter had heavy gas fees for those of you who are already into cryptocurrency and was aware of that will notice that you had to pay heavy gas fees because the usage was so high. Now it's a lot better. So it's important to remember that throughout every transaction that gets acted upon onto the blockchain, there will be a gas fee that comes with it. And this is the limit. So we don't want to go over this limit. So this is our gas limit. We've got 1, 2, 3, 4, 5, 6. So our gas limit here, 3 million. Now the value over here, the value under the gas limit is effectively the amount of ether that the owner account, that's going to be the first account here, is going to allocate into our smart contract. Now, if you remember in our constructor, we made it payable. And the reason why we did that was that so that we could transfer out an amount of ether into the smart contract so that we can allocate those funds when we're paying out with our inheritance to each family member for our friend's great-grandfather who is passing away sadly, tragically. All right, so this value, we can initialize it whatever we want. So for the sake of argument, we're going to say, well, our friend's grandfather had a total amount of 30 ether. Okay, so we're going to set the initial value to 30, and now you're going to see different measure units, And these are units of Ether, essentially. Way is the smallest measurement of Ether, and Ether is just 1 Ether for 1 Ether. So the value of 30 Ether will be just 30 Ether, right? Whereas the value of 30 Way would be essentially 1 over 3 to the 3018 0 decimals. So what do I mean by that? Well, essentially what I mean is, here, let me scroll down so you can see, when you think of the US dollar and you think of the decimals after the US dollar, we always think of 2, right? When we pay for things. If we're buying a chocolate bar or we are taking a ride on the train or the bus, we will think about 1 point something something. Now, when we think of cryptocurrency, however, we can think about decimals that can range all the way up to many, many, many decimals. And Ether has 18. So without getting too deep into that, because we do a full discussion and we go in depth on this when we actually build out our smart contracts on our development server, I just want you for now to bear in mind the difference of value between Way and Ether. So I'm going to switch the value now back from Way to Ether. So that way we are now allocating 30 Ether from this smart contract will when we deploy the contract. Okay. So that's it in terms of our parameters and our parameters to set up a successful deployment. The next thing we need to do now is actually deploy the contract. So go ahead, make sure you have everything set up correctly. You can double check it. Make sure you have successfully compiled the contract and there are no longer any errors and you've gone through the whole debugging process. And once you are sure that everything's good to go ahead and click on deploy. All right, so let's deploy this down. And once you are sure that everything's good to go ahead and click on deploy. All right, so let's deploy this down. Okay. I have now deployed the contract and we can see that it's successful. 2 places here. We can actually see deployed contracts at the bottom left side of our IDE. We see deployed contracts and underneath we see the will, and that's the name of our contract. And we have a contract address that is specific. Now remember, this address is not the same as the address of the account where we allocated the Ether. Okay, this is actually the contract address set up on the blockchain, and this contract is a smart contract that allows us to run functions. So hopefully now you're starting to get a better sense of the power of smart contracts with blockchain technology. Okay, and the other thing we can see here is if we go to the console, we're going to actually see a check mark and it says virtual machine from this address, and if we check what this address is, EDDC4, it's not matching the deployed contract address, but it actually matches the account address, and that's good because we deployed from that account address. So that's the will. We see the constructor. We see a value of 30 to 18 decimals. So I don't know what that is. It's a really, really massive number, but we see that it's Way. So converting this number into Ether is actually just 30. So for now, ignore all the zeros after 30. Just focus on the 30. Okay. And if we want more information, we can click on this arrow over here next to debug, and it's going to scope down and tell us the status. The transaction mined and executed was successful. We have our transaction hash to what, which was will, which was our contract from the constructor. We see gas, transaction costs, the execution cost. So this was the gas fee. Notice how it does not go over 30. How it does not go over 30 million. 1, 2, 3, 4, 5, 6. It does not go over 3 million. We have our input. And we have the value, which is the value that we set initially. Okay, so effectively now, our contract is deployed. And right, so the next question we should be asking ourselves is, all right, so how do we actually enact this contract on the IDE? If you actually look back to underneath the deployed contracts tab on the side here, we'll see an arrow. And this arrow is right next to will at OXD91. And if we click on this arrow and we scroll down, we're actually going to see two buttons. We have a has deceased button and a set inheritance button. So can you guess what these buttons are? Well, hopefully you see the has deceased button is actually a trigger to run this function has deceased. So this is this is in effect our oracle, which is going to be giving us that information from the outside world, right? That once our friend's great-grandfather passes on, this button is to be triggered. And if this was an oracle, we would actually write this into a function and say, function which would check for that information specifically and automate the process. Okay, but we're doing it manually for the sake of learning about the smart contract workload. All right, underneath has deceased, we see the set inheritance. And if we click on the arrow of set inheritance, it actually opens up two argument text field inputs, one that's wallet and one that's amount. Now, can you trace where these came from? Well, hopefully you see that if we go to set inheritance here, we had two arguments set up in our function set inheritance. So we had our wallet and our amount. So this provides us with everything we need to run the smart contract. So let's go ahead now and test this smart contract. Let's test to see that it is truly successful. So how do we do that? So what we're going to do is actually set the inheritance, right? We're going to add to our list of family wallets. And we're going to do that by putting in wallet addresses and amounts. So we know that we have a total of 30 Ether. Now let's say that our friend's great-grandfather is alive and he has access to actually add the inputs. So he can say he can go on his computer to some secured network, to some secured device, and say, all right, my favorite great-grandchild, or our friend Johnny. So Johnny, who has let's say the third account here, this account that ends in 733C. Now your account numbers are going to be different because these are randomly generated, but just the third account. So don't worry if the numbers are different. Well, he's going to say, well, this third account, and he's going to copy it. And you can copy it as well if you just click on the copy button to the right of the account. You copy it to the clipboard. Now we're going to switch back to the first account. Well, we're going to say for the sake of argument that this is Johnny's wallet address. So we're going to add strings. So we're adding quotations because we're going to turn the wallet into a string. So it'll be read that way. And inside the strings, we're going to paste the wallet address. Okay. So there's the wallet address. And then underneath this wallet address, we are going to add the amount. So let's say Johnny gets the majority. Johnny is going to be getting 25 ETH. Now, just a heads up, this amount actually isn't in Ether. It's in Way. So you're going to have to what? Well, you're going to have to add those zeros, right? So that's 18 zeros. So make sure that you add them. And later on, we're actually going to build functions to convert that for you. So we will build these helper functions so we don't have to deal with writing this all the time. But for now, again, we're just getting introduced to these topics. So we'll just manually put in 18. Okay, so this is Johnny's information. This is what he gets. That's the wallet. That's the amount. So we're going to go ahead and click on Transact. And by clicking on Transact, hopefully we are adding this wallet and this amount to the address, to the list of addresses. So we click on Transact, and if we look down again, we're going to see that there's a successful transaction happening here. Okay, so now let's try and do the same thing, but for his other great-granddaughter, Susie, Johnny's cousin or sister or whatever. Okay, so now Susie, let's say, has the account that will be the second account over here. So we're going to do the same thing. We're going to copy it. Go back to the first account. Oops. And this time we are going to get back to our string over here, and we're going to paste it back in our wallet. All right. And now we're going to switch this to the remaining balance, which let's say Susie gets the rest. So that would be 5. And we'll keep the 0. And we'll hit transact. So let's hit transact. Okay. So now we have a second successful transaction underneath the first one, right? Excellent. But if we scroll up and we look, we're going to notice that nothing has happened, right? And why hasn't anything actually happened? And what do I mean by nothing's happened? I mean that we only still have 100 Ether in each account. That means that none of these transactions were allocated. Well, why is that? And I'll let you think about that while I have a sip of coffee. Okay. So none of these transactions have been allocated because our dear friend's great-grandfather is still alive, right? Technically has not deceased. We have not triggered the has deceased function yet. So let's say that sad day comes suddenly and he passes on to greener pastures, into the cosmos and the great unknown. So that has happened, and now it's time to initiate and execute the has deceased function. So let's go ahead and click on has deceased. So we're going to click on has deceased, and we should see another transaction goes through, and the has deceased, and this is another successful transaction. So remember that we are actually interacting right now with our smart contract and the blockchain by executing these functions, right? So now that we've clicked on has deceased, what has actually happened here? Well, it has changed our deceased boolean to true, okay, and it has executed a payout. And what is payout? Well, payout is supposed to be the loop which actually pays out the set inheritance which we have set previously with the addresses previously. So if I scroll up now and I check the balances, well, there you have it. Hopefully, maybe I can make this bigger so you can see it better. The first account now went from 100 to 105 Ether. And that's because and that is Susie's account, right? And Susie's account got an additional 5 Ether, which was allocated in the contract. And now Johnny's account underneath got 25. So Johnny's been given his inheritance, and Susie has been given her inheritance. So this has been a successful deployment and transaction on the transaction via smart contracts. So if you've made it through to this point and you've successfully completed this, then congratulations. You have, in effect, put up a simulation of a contract will, of a contract will in the light of what the applications are about. So way to go. You're on your way to becoming a DApp master. There's a lot of fundamentals that we covered here, and this may seem simple enough, but really these are all the building blocks that we need to be going back to, and we will be over and over again, i.e. setting global variables, getting familiar with the syntax of writing in Solidity, with static types, variables, writing constructors, making use of the public, the payable, of public and payable, understanding our methods and our variables such as message sender, writing the logic that we need to ensure that things happen the way they should happen with modifiers, mapping out addresses. Mapping out addresses are important. Mapping out and creating key store values with integers to keep track, so that we can keep track of our addresses, and writing loops to iterate. And then finally running transactions, right? Such as the transfer. Okay, so for your exercise, your exercise is going to be to remove the has deceased function. Okay, so we're going to remove this has deceased function. And now we are going to remove the contract, okay? And I do that by trashing the contract here. All right, already X'd it out. And then we want to go back to our compiler and recompile our contract, okay? And then now, without the deceased function, go ahead and try to do the same thing that we just did. Allocate funds 30 Ether to 2 separate accounts and divide each amount. And find a way to do that. Now, if you want to try to actually rewrite the deceased function, that could be one way to do it. But there are other ways to do this, and I'm gonna leave it like an open book. So hint, hint. If you look at deceased values where they're set, another hint, triggering the functions. And if you want to be smart about it and build it in a way so that it's conditional for real world logic, then that's extra bonus. Then that's an extra bonus. So go ahead and give that your best shot. Again, if this is the first time you're going through, there's a lot to process here. But the more time you spend on your own fiddling with it, the better you're going to get the hang of it. The better you're going to get the hang of it. So it's great to be coding along. It's great to be following along. And it's even better to do that and then take the time afterwards to test yourself to see that you understand these things as we move from one subject to the next. All right. Excellent work making it to the end of this. We've got a lot more to cover in this course. So give that exercise a shot. And once you've finished that, take a break, do a little celebration dance, and I'll see you in the next video. Okay. Bye-bye.